Hi, in this video we are going to solve two problems on the assignments for section 6.6 or the surface area. Problem 13. Find the area of the surface by the given curve. This is the curve. It's revolving about the x-axis. So the x-axis is the axis of revolution. Now y equal x to the third power over 3 plus 1 over 4x. This is the curve on 1 over 2 to 2 on the x-axis. Okay, so we know that for the surface area, the formula for the surface area is the s equal to 2 pi from a to b. This is the limit on the x-axis. R of x is the radius from the axis of revolution to the curve, and then multiply by 1 the square root of 1 plus f prime, the whole quantity square, and then dx. Now let's take a look at the graph of this function. So this is the graph of this function. So this is the graph of x to the third power over 3 plus 1 over 4x. And because we are only focusing on the interval from 1/2 to 2 on the x-axis, so this is 1, this is 2, so 1/2 is around here up to 2. So imagine that we have this is the whole graph of the whole function, but I only take the interval from 1/2 up to 2, so that should be this plane region here, and then I revolve the whole thing about the x-axis. So I should have this whole object here revolving about the x-axis, around the x-axis, and then you just want to find the surface area of this whole solid object here. Okay, so the function r of x that you see in the formula here, this is the radius from the axis of revolution up to the curve, and if you look back to the function here, this is the axis of revolution, the x-axis. This is the x-axis. So we take the distance from the x-axis up to the curve, which is the radius. And you see that the radius is changing. It's small here, and it gets larger and larger and larger as we move to the right. So the radius is depending on the x as we move along the x-axis. The radius is changing. And the radius r of x is just the function f of x, because this is just the height or the value of the function f of x, which is this curve right here. So r of x in this case just the f of x, which is the function. It's simple, right? Okay, so go back here. So we know that r of x is now just what? It's just the function f of x, and the function f of x is given by the curve, which is x to the third power over 3 plus 1 over 4x, which is right here. So this whole quantity here is r of x. And then 2 pi, this is a constant. I move it to the outside of the interval from 1/2 to 2. Okay? And then the square root of 1 plus f prime, the whole thing square, and then dx. We are running on the x-axis, so it should be dx from 1/2 up to 2. And then the next one is I need to find f prime of x, so I can take the whole square. Now we are given that this is the f of x function, which is x to the third power over 3, and then 1 over 4x. The x at the bottom here, I can just move it to the top, the numerator, right? So if I move the x to the top, that's become -1 to the -1 power. And then when I take the derivative function of f prime of x, then I use the power rule. Bring down 3, bring it down, and then subtract 1 from that, that's become 2. And then bring -1 down here, that's become -1/4. And then subtract 1 from -1, that's become -2. And then here you can simplify this one to get x squared, and then -1/4, and then x to the -2 power. And then we need the square here. That's why the whole quantity square, that's become the whole thing you just found here, and then square. So we plug in everything to the formula. So 1 plus f prime square, which is this whole thing here. I brought it down here. Now the next thing is you need to simplify the expression so that you can find the integral. It's very difficult to solve for the integral here. It's look like that we cannot use any of the rule we learned so far. Even for the u sub, it's very difficult. So the best thing now is that I'm trying to simplify the quantity inside the square root. So let's try to expand the square out and see what I can do. Okay, so we know that the square root means everything to the power of 1/2. So I did not change anything yet. I just rewrite the square root into the power of 1/2. And then now let's try to focus only on this term here, right here, the one under the square. So let's try to simplify the whole thing. And this is the addition here. So I use the x plus b, a plus b square equal a square plus 2ab plus b square. And you can see this one is a, and x square is a, and then 1/4 x to the minus 2, that is b. Okay, so I keep the 1. So a square, so x square square minus 2ab, 2a is x square, b is 1/4 x to the minus 2 power, and then plus b square, and b is 1/4 x to the square, the whole quantity square. Simplify it. X square give me x1, x4. Now the 2 and the 4 they cancel, so I get 1/2 x to the square and minus, so you add the power. 2 minus 2, that's 0, so x to the 0 is just 1, so nothing for the x now. So 1/2 for this term, the middle term. And then 1/4 x to the square, and then the whole quantity square. 1/4 square give me 16, and then x minus 2 square, 2 times minus 2 is minus 4. And now you can combine the like term. 1 subtract 1/2, that's become plus 1/2, x to the 4th power is right here. And then 16, 1/16, this is the same thing. And then you can see that I can use another property. A plus b square becomes a square plus 2ab plus b square. And then I can see that x to the 4th power, I can rewrite that into x square and x square. And then 1/2, this is the middle term. I know that this is the last term, so I can rewrite the last term into 1/16, so 1/4 x to the 4 minus 4 power, I give minus 2, and then the whole quantity square, so that when I square it back, I should get what? 1/4 square give me 1/16, and then x minus 2 square is minus 4. So I know this is the a square term in here, this is the b square term in here, so the middle term should be 2ab. So 2a is x square, and then b is just this term. And let's try. You can see that x square and minus 2, the 2x, they cancel, right? They give you x to the 0 power, so which is 1. And then 2 and 1/4, if you simplify the top and the bottom, you should get the whole middle term here is plus 1/2, and which is this term here. So we know that this is the property of a square plus 2ab plus b square. And then from there, we can just rewrite the whole thing into a plus b square. And the reason that why do I rewrite the whole thing here square? The reason that this whole term here, 1 plus that whole term now become this whole thing square. And then because the square here and the 1/2 here, 2 and 1/2, when you power to 1/2 outside, 2 times 1/2 just become 1. Or you just take away the square root, which is right here. Because the whole term under the square root now becomes something square. So the square and the square root, they cancel out. Or if you rewrite this term here, you got 2 pi, 1/2 to 2, 1/2 to 2. And then the whole term here, the same thing. And then this whole term here, we just file it here. for this whole quantity here to the power 1/2, and then 2 over 1/2 they cancel out, so that at the end you can take away the 1/2 and the 2. Okay, so this is now easy. We just have two binomial term. Now let's try to FOIL them and see what we get here. Okay, let me go to the next page. So let's FOIL them and see what we get here. Alright, let's FOIL it. Okay, so FOIL the first term to the first term. X3 and X2 give me X5, and then the 3 at the bottom stay the same. X3 and X minus 2 give me 1X. 3 and 4 at the bottom give me 12. Multiply them together, and then 4X times X squared. The X squared and they cancel out with X, so 1X on the top, and then the 4 still at the bottom. And then X minus 2, X minus 2 and the X at the bottom, this is the division, right? So minus 2 minus 1 give me minus 3 for the power of X, and the 4 and the 4 give me 16 here. So I FOIL everything here to get the whole quantity right here. And now let's combine them together. We can see that we have the X term. This is the X term. So we can combine them. 112 plus 14 give me 1 over 3 and with the X. And then X to the 5th power over 3 stay the same, and the last term stay the same. And now all you have now is just what? The 3 terms that we got here. This is just a polynomial, easy to find the integration of minus 1/2 to 2, and by using the power rule. So this is the power rule. The 5th power, I add 1 to that, becomes 6. I divide by 6, but we already have 3, so 6 times 3 is 18. This is the power of 1, so 1 plus 1 is 2, divided by 2, but 2 times 3 is 6. And then minus 3 plus 1 is minus 2, and then divide by minus 2. Minus 2 times 16 is minus 32. And we evaluate the whole expression from 1/2 up to 2 because of the limit right here. And then all you do now is we keep the 2 by from the outside. We plug in 2 for everywhere you see the X, and then subtract, plug in 1/2 for everywhere you see the X, which is the next term, and then do all the calculations here. You should get with the 2 pi multiplying with the 2 pi, so that should be 275 pi over 32, and that is the surface area for the curve revolving around the x-axis. So let's go over the next problem. Okay, this is the next problem. The same section 6.6, surface area, and this is problem 19 from the textbook. Now for this one, we are trying to find the area of the surface generated by the given curve, which is this one, y equals 4x minus 1. And this is revolving about the y-axis. So make sure that we pay attention to the axis of revolution. This is the y-axis. And the part of the curve between the points 1, 3 and 4, 15. So let's just quickly graph the function. Now please note that this is not a scale graph because I don't have enough spaces right here. So we know that this is the linear function. Minus 1 is the y-intercept. The slope is 4, so I go 1, 2, 3, 4, go to the right by 1, and then just connect the line together. And I know that I just need the part of the function, the curve from 1, 3, which is this point, and then 4, 15, which is 4 and 15 here. It should not be here. 4 should be around here, 15 should be all the way up here, but I don't have enough spaces. So I assume that this is not a scale function. This is just an example. So we imagine that this is 1, 3, and this is 4, 15. It should be on this line. This is the linear line. So now we're just revolving this line, this curve, around the y-axis. So we're revolving around the y-axis, okay, to generate an object, and then we just want to find the surface area of the whole thing. Now, what is the formula for the surface area? This is the y. This is revolving around the y. So let's just assume that we go with dy in this case and see what happens. Okay. So the same thing. 2 pi, as you saw in the last example, 2 pi is always in the front, and because we choose to use the y dy due to the y-axis. Let's try with the y-axis in this case, and we can go from C to D. This is on the y-axis. It's running on the y-axis, and then this is the radius in terms of y, 1 plus f prime of y, the whole quantity square, and then dy. So when you get dy, everything here should be in terms of y. There's no more x here. Now, r of y is the radius from the axis of revolution up to the curve. This is the axis of revolution y, which is from here to the curve, which is this distance, right? R of y, right here. This is r of y. Now, what is this distance? R of y, this is just the distance of x, right? This is just the distance of x, because as you move from this point, this is some value of x, and then as you move up, another value of x. As you move up from here, the x gets bigger. So the x gets bigger. So we need to find the expression for the x, because this represents for the radius, right? As you move up the curve from 3 to 15, because we run on the y, so we go from 3 to 15 on the y-axis. So as you move from 3 to 15, the radius gets bigger. So we need to solve for x equals something, because we need the expression for the x. We are given y equal 4x minus 1. So I can solve for x easily. And x here is a distance that you see here. It's changing. It's changing as you move on the y-axis. X gets bigger. Therefore, x is now in terms of y. That's why changing, x gets bigger. That's why this whole thing here is just the radius of r of y. Okay. So we know r of y now is just x, which is this guy here. And then f of y is the function in terms of y. This is f of x, y equal 4x minus 1. This is also known as f of x. So to solve for f of y, all you do now is you are solving for x, and the x is just f of y, because this is the function in terms of y. So y plus 1 over 4 is f of y. And then you can split this one into y over 4 plus 1 over 4, so that we can take the derivative function f prime of y. Now using the power rule, this is the variable y, so the power of 1, so that becomes a constant 1/4. The derivative of a 1/4 constant, that becomes 0. So all you get f prime of y is 1/4. We need that for the formula that you see here. So r of y, which is this guy here, right here. And 1 plus f prime of y. F prime of y is 1/4, so 1/4 square dy. And then you can simplify that further. 1/4 square is 1/16. We keep everything the same. 2 pi stay outside. Now we can add 1 and 1 over 16 into 17 over 16. Now the square root of 16 at the bottom, I can take the square root to the outside, so that becomes 4 when you take away the square root. And 4 times 4 here is 16. However, there's a 2 at the top, so 2 and 16, they cancel. So at the bottom should have 8, right? It's have 8. And the constant of the square root of 17 also come to the outside. And then the pi stay the same as pi. And now all you have now is just y plus 1 inside the integral, and then dy. And now we keep the whole constant here on the outside. This is the power rule: y squared, add 1 to the top, divide by 1, which is divided by 2, which is 2. And then the 1 becomes y when we take the integral of 1. And then we go from 3 to 15. And then it's easy. All you do now is you do the substitution of 15 to everywhere you see y, and then subtract 3 to everywhere you see y. And then if you finish all the calculations, you should get 15 multiplied by the square root of 17 and multiply with pi. Now this is the case where we go on the y-axis. Okay. Now imagine that you still want to go with the x-axis. So what happened to the x-axis if I choose to go with dx instead of dy? Okay, if you go with dx, then everything in here should be dx. Sorry, it should be in terms of x. 2 pi still stay at 2 pi. Now c to d is becoming on the x limit, so it's go on the x-axis. We had 3 to 15 on the y-axis for the limits, but now because we go with dx, so everything should be in terms of x, and we also go on the x limits. So this is the curve on the x limits is running from 1, because this is 1, and then this is 4 for x, so it's going from 1 to 4 for dx. So 1 to 4 should be the limit. Okay. Now the next one is the radius. The radius is still the same, which is the distance between the axis of revolution up to the curve. Before we found that to be x equals something. X equals something, right? Because as you move along the y, x gets bigger, 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 bigger. So r of y is just the radius is just x, and x is this expression right here, the whole quantity in terms of y. Now because now we are running on the dx, so we don't need to write the x in terms of y. Therefore the radius now is just x. We don't need the x to be in terms of y. Before we use y plus 1 over 4 for the radius, but now it just become x, because this is already in the x term, which is dx, which is good. And then the next term is what? The next one is 1 plus f prime of y, the whole quantity square for y f prime of y. Now because we are dealing with the dx, so everything should be in terms of f prime of x, not f prime of y. And we are given this is the function f of x, right? So f of x is equal to 4x minus 1. F prime of x, the derivative function of this one, that's become 4. Minus 1 becomes 0. And then if you square that, you should end up with 4 squared equals 16. Or 1 plus f prime of x squared, which is 16. And then dx. So if you do the if you find the value of this integral from 1 to 4x multiplied by 1 plus 4 squared 16, 16 plus 1 is 17. So I bring the whole thing 2 pi square root of 17 from 1 to 4x dx. Then if I do this integral here, let's try. This is the power rule, so x squared over 2. And then we evaluate the answer from 1 to 4. And we still keep the 2 pi and then square root of 17. So I plug in 4 to, let's skip 2 pi and then square root of 17 outside. And then we plug in 4 to x, subtract, and plug in 1 to x. So 1 squared over 2. Now let's try. This is 16 over 4 squared 16, 16 over 2, that's 8. And then 1 square is 1, and 1 over 2 is 1/2. And then 2 pi square root of 17. and let's try to see what is the value of this one. So 8 minus 1/2, this one is 15 over 2. So 15 over 2, 15, let me write here, 15 over 2 times 2 pi square root of 17. So the 2 they cancel out, so you have 15 pi and then 17. Okay, let's compare the answer that we got earlier. Before I got if I use a dy, then I end up with 15 square root of 17 pi, and if I use the dx, I also got 15, 17 and pi, the same thing, right? Two of them, 17 square root of 17, 15 pi, the same thing. So this is also good. So it looks like that for this example, it is much simple to use the dx, because the integrand inside the integral here is very simple. You can do it quickly, and then if you use dy, you still end up with the same value. But then here you have to go to a lot of simplification, and you still do end up with the same thing. Okay, so thanks for watching.